All right, sorry we're running a little late, everybody. Good morning. My name's Austin Whiteley. I'm a mechanical equipment salesman out of our Fort Collins office. Today we have Pat from Multistack here with us to discuss chiller system design for constant flow and variable flow applications. Pat, can you jump to that next slide, please?
Sure.
Since we won't be diving into the Multistack product line in detail today, I just wanted to briefly highlight this slide, which gives us an overview of the Multistack product offerings. Multistack is a manufacturer for modular and packaged chillers, including air-cooled, water-cooled, and heat recovery options. If you would like more information about the Multistack product line or would like this slide, please reach out to your sales rep for more information. With that being said, Pat, I'll let you take it away to discuss some system design.
Perfect. Well, good morning, everyone. Thank you for your time this morning. We're just going to do a very high-level dive into something that we have learned to be very important with respect to how our systems are designed and to make sure that you have a successful application along the way. So today we're going to talk about primary, secondary systems, and most importantly will be the difference between constant flow and variable flow design. Over our history in the last 10 years or so, we've learned that the application of the modular chillers perhaps has been a little bit not as focused as it should be on some of the key features of making it successful. So there's two primary types of systems. There's a constant flow type of system, very common in existing buildings today, typically really good for small chilled water loops, but as the space has grown, a lot more activity is happening, and most designs now are heading to variable flow type of application. Most new construction has some kind of variable flow somewhere in the system, and ASHRAE 90.1 even requires VFDs on pump motors that are bigger than 10 horsepower. So variable flow systems come in 3 or 4 different varieties. Variable primary flow with either conventional chillers or with modular chillers, and then constant or stepped primary with a variable secondary loop somewhere in the system, or variable primary, variable secondary. So a lot of ways to design your buildings, but today's mission is to kind of give you some of the key things that we need to be thinking about as we do variable flow types of systems. Typical old constant flow system would have fixed speed pumps, a balancing valve, and a VFD for flow balancing only. In this case, they would have terminal devices with 3-way valves, generally lower energy efficiency, but they're easier to commission. But anymore, the new systems, and particularly the modular systems that Multistack invented, do require or actually function better. You can still do a modular machine with constant flow, but it's going to perform better, have higher energy efficiency if you employ the principles of variable flow analysis. So what's different? No balancing valve, and the pump changes to match up with what the building load is required. So if you just sort of think about that, that will lead to some energy efficiency gains in the building so that you're only pumping to the speeds that you need. The terminal devices only have 2-way valves in this instance. So that makes for a little bit lower cost, a little bit easier system on that side of things. The minimum flow of the chiller and the pump flow. One of the mistakes that we made in the early days was we didn't give you enough information as a customer about what that minimum flow was, and many times problems in the system were a result of not having enough flow to the machines. There is a minimum flow, and that has to be achieved. We've taken some steps, and I'll show you at the end, to make that easier for you to do. Compared to constant flow machines, variable flow systems are going to be more energy efficient. The ability to match the load is critical to doing a variable flow system well. They are a little bit more complex to commission. You need to have a good relationship with the building controls folks, but it will end up saving energy, and we're all being pushed towards greater, higher energy efficiency as we progress in the market space. Variable flow systems, it's critically important that you get your DP sensors in the proper space, because that is the primary way that we control the application of the operation of the system, and we tell you essentially where to put those through some calculations. But this is an example of a variable flow system with DP sensors in the proper locations. Let's talk about variable flow in a little more detail. We invented variable flow when we built our modular chillers back in the mid 1990s. So the technology and the development, the use of variable flow is 20 plus years old. What's required for modules? There's a motorized valve for every heat exchanger. So if you have say a 4-module machine, there will be a motorized valve for each of the heat exchangers. 2-position valves for ASP, which is air cooled, and a turbo core, which is the MS-80, and then all the others are water cooled or different varieties of air cooled. You can do entering or return water controls, but our recommendation is that we do leaving water controls on all the modules. There are 2 primary ways to manage the DP settings in a particular machine. You can do pump control to the chiller DP and bypass control to the system DP, or vice versa. Control the pump to the system DP and control the bypass to the chiller DP. We don't really have a preference, but there are multiple ways to do it. What does that look like? And what are some of the recommendations? This first machine, there's going to be another one that pops up here in a second, but some of the requirements, and these are critical because we've missed these in the early days, and we're working our way back to get people corrected there. But the valves have to be fast acting. They have to be less than 60 seconds. Anywhere from 30 to 60, 30 is better. The other piece that we often found will delay. So we got to be with your controls contractor and say, do not delay for any period of time. Make sure that that signal gets to the controllers and that they immediately start to function. We will tell you what minimum loop time is and loop volume is at all load conditions, and that has to be managed via DP settings, but we'll actually show you how we do that when you make a selection. So we've tried to take some of the guesswork out of the system. So the DP sensor has to control either the pump or the system bypass valve. There has to be some proof of flow device, because we find all the time that some of the pressure problems, either low pressure or high pressure, are either condenser side flow problems or evaporator side flow problems. So while it sounds complicated, we're trying to make it much more simple for you in the field, and the guys at Long are becoming experts at how to do the analysis and how to make sure you have a successful application. People also always want to employ 3-way valves, and that is not required with a variable flow system. 2-ways motorized fast-acting valves are the way you want to go with a variable flow machine. Now, in this particular case, this first picture is showing that DP is controlling to the VFDs, and I don't know if you can see my cursor. So if you look at the drawing, the bottom dashed line would be DP controlling to the VFD or to the pump, and then the top dashed line that runs over the top of the air handlers is chiller and bypass control with DP. The version next just is the reverse of that. It's bypass control to the DP and pump control to the chiller on the DP settings there. We give you all that information so that when the machine is commissioned or started up, whether it's done by a Multistack technician or whether it's done by a representative field service certified technician, we give you that information. A slight difference would be, now that was variable primary, this is primary secondary, which has multiple loops. We'll also show you the calculations on what the DP requirements are and the minimum flow requirements are. But in this case, for those who aren't familiar with primary and secondary design, you have multiple loops. The primary loop serves the prime movers, which are the chillers, whether they're an air-cooled chiller, whether they're a heat recovery machine. Conceptually, it's all the same. Primary loop handles the chillers. Secondary loop serves the building itself. In a primary-secondary system, the system decouples that primary loop from the secondary loop with one of a number of technologies, either a bridge or a decoupler, piping basically, or a storage tank, or another heat exchanger employed in the system somewhere for some reason. So there's basically 3 ways to decouple the primary loop from the secondary loop. Again, not necessarily mysterious, and we don't have a preference. We can manage through both types of technologies, but there are other ways to control a building, and we're learning how to help people be more successful with that. Excuse me. I mentioned earlier there's a primary, variable, secondary machine setup. So this one, primary movers, chillers 1, 2, and 3 on the left side, controlled by primary pumps. And then there's a decoupler that runs down kind of the third of the way through the screen. I don't know if you can see my cursor, but right there, there's your decoupler there, which handles the chiller side. And then the secondary pumps manage the push to the air handling units to the building or the load side of the operation. Variable primary, variable secondary would look something like this. This is similar to the diagram before. Notice the addition, notice where the temperature sensors are. There's one out on the far end of the loop. There's another one right here at the top where we go into the secondary loop. We want to make sure we understand what the temperatures are in that loop, because if we're just running in this first primary loop on the right side, we may not capture temperature changes that are coming back to us. So we need to just know what those temperatures are as well. 2 DPs, one on each side of the chiller, and then the primary loop is managed in that fashion. So a couple of ways to get at the system. I told you that the outset that we would try and kind of give you a sense of what it might look like and what we provide for you. So this would be a selection that would be created by Long or by our inside sales team. And there's a couple of key items in here that help you along the way. If you go down into this slide where it says pressure drop, chiller minimum flow, and minimum GPM, both on the evaporator side and the condenser side, those pieces of information are critically important to sizing your loop properly. This top information just tells, in this case, we're doing 5 70-ton heat recovery machines. Not necessarily that you know that right now, but that would do about 350 tons nominal. We're asking it to do about 270 right now. But these 3 pieces of information that I just mentioned are really important. And I'll jump back and forth, but the first piece of information that you would get in a selection would be something like this. And I'm going to roll up another piece here. Most important thing you do once you understand your load is size the bypass properly. And those 3 or 4 pieces of information, recall the prior slide where the DP setting was to be 5.59. The minimum flow, 128.7, is the amount of flow through one machine. That flow has to be maintained in order for the machine to run properly. And the bypass valve has to be assigned for 193 GPM. So it's basically 1.5 times the minimum flow. And then the bypass loop volume has to be about 806 gallons. So all of that has been calculated for you. That allows for about between 2 and 3 minutes of loop time. 2 is minimum, absolute minimum loop time. Many people in the field are applying anywhere from 3 to 5. But these are those 3 pieces of critical information. Most important that we size the bypass properly, that we get the loop volume proper, and that we control properly. And that means that we manage the controls to those DP settings. And our system is designed to do that. We want to make sure that the controls team is not doing anything that is different than what these minimum requirements are. So that was the evaporator side. Here's the condenser side. And I'm going to bring those 3 items up again because they're critically important. But if you recall back to the prior slide, 2.597 is the DP setting on the condenser side with 87.5 GPM and 131, and the gallon GPM tank size of 577. So I'm going to skip back up and show you those. We've already provided them for you. There's your 2.97. Your 87.5 and your 131. So we're trying to assist with proper system design. That is a variable primary flow system. We also do the same provision of information with the primary secondary type of application where we have same information, 5.59 PSI, because that's what's required for this portion of the loop. So it doesn't really change. What we've done is we've said, this is how you control the primary piece, and we're going to be monitoring what's happening in the secondary portion to make sure that this portion of the unit stays in control. And that's evaporator side, condenser side, same thing. There's your 2.597 and 87.5 gallons. So critically important that we pay attention to the information that we're given and run and design the system in that fashion. So at this point, Austin, that kind of takes us through a very high level quick tour, but I'll open the floor to questions or however you want to roll from here.
I don't think we're going to be able to do questions because everyone's mics are muted in this.
Okay.
But if anyone does have any questions, feel free to reach out to me or your sales rep, and we can help handle that. Pat, thanks for joining this week. I appreciate you taking the time to put this presentation together and walk us through the different types of variable flow and constant flow designs. If you could jump to the next slide.
Yeah.
Thanks for joining. Next week, Nick Bryant will be here discussing Envirotech's product line and future offerings. Thanks for joining.